Hello, welcome back. We're still on section 1.1 arithmetic sequence. We're going to pick up on example 3. So let's look at the following arithmetic sequence. We're going to try to determine the seventh term. All right. So we have this pattern. There's only three. We have the sequence. Sorry, there's only three numbers in the sequence, which we need at least three numbers in order to determine the next terms, unless we know what type of sequence it is. So you can clearly see that we're adding 7 each time, so that's the common difference. So determining the seventh term is pretty easy if you want to do that by just adding 7 4 more times and getting a number. However, sometimes you're asked to find let's say the 100th term. So instead of writing out 100 numbers, what we're going to do is we're going to come up with a formula that allows us to find we call it the nth term, or the general term, which we're going to develop that right now. So this is just an exercise to help us develop where the next term comes from. So to get the first term, that's pretty straightforward. To get the first term, all we need to do is to get the first term, that's just going to equal the first term, obviously. So that would be 19, for example. So that would just simply equal T1. However, the second term, how do we get to the second term? Well, we've determined that the common difference that we've determined in the previous example 2, is how we get to the next term. So that we've just decided that D here is going to be plus 7. So to get from negative 19 to 12, we have to add 7. So the first term we know is negative 19. To get to the second term, it's going to be term 1 plus the common difference. So that is obtained by term 2 equal to term 1 plus D, our common difference. That allows us to obtain our second term. So how do we get the third term? Well, the third term is going to be taking the common difference and doing it twice. So essentially, what that means is our third term is going to equal, well, again, of course, our first term plus D, but it's also going to be plus another D. Because if we take negative 19 and we add 7 to it, we get negative 12, and we add 7 again, we get negative 5. So that can be simplified to T1 plus 2D, because D plus D is just simply 2D. So we get this information here. Okay. What about the fourth term? How are we going to obtain the fourth term? Well, the fourth term, you're probably seeing a pattern. It's increasing by the common difference every time. So this would be the 3D. So it would be T1 plus 3D. Notice the coefficient in front of the D is 1 less than the term that you're trying to find. Would that work? Well, let's make a prediction. What would our next term be by adding 7? It would be 2. Well, let's take a look. What's negative 19 plus 3 times 7? Well, 3 times 7 would be 21, plus negative 19 will give us 2, which is our predicted next term. So we'll do one more here. I'm just going to cheat and copy and paste this. So the fifth term that we're looking for is, again, the first term plus 4. So it's 1 less multiplied by the common difference. So we're going to replace that with, instead of using the number 3, 4, because we're going to try to guess this for the nth term. So t to the nth term is going to simply equal the first term, and instead of putting a whole number in there, we're going to call it n minus 1, because it's 1 less than the term we're trying to find, the nth term. So this is the formula. We've just developed the formula that we use to find a term in an arithmetic sequence. So as long as we have the first term and we know the common difference, and we know that as long as we have 3 numbers in the pattern. Of course, there's going to be some examples where we're going to have to look for different items. But at the end of the day, this is what we've come up with. So we'll just put a general term in here. So our formula that we're going to carry with us, that you will be given, is t to the n is equal to the first term, t1, plus n minus 1. So basically, if you're looking for the 10th term, it's going to be 10 minus 1, so it's 9 times your d value. And again, this can be rearranged, or we can use it for whatever we need. So we've developed the formula for that. Let's continue on with example 4. So in example 4, it says we have an arithmetic sequence, 26, 29, and 32. It says determine the values of t1. So we literally just have to list these. So we would say that t1 is equal to 26, and d is equal to 3. And we simply get that by taking 29 subtract 26 equals 3. You take the second term, subtract the first, or the third term, subtract the second, and you will end up with 3 for your common difference. So d is equal to 3. The next question, example 4b, says determine a simplified expression for the general term. So there's two formulas we have for this. The first one is going to look like, again, I'll just bring our formula, and we have it Tn is equal to Tn is equal to T1 plus n minus 1 multiplied by b. So what we're going to do now is we're going to take our formula and we're going to add in what we know. So the nth term, that's the general term, that's t to the power of n, or sorry, t to the n, excuse me. The first term, we'll replace that with 26 plus n minus 1 d. We don't know n, but we do have the common difference. The common difference is 3. So we'll put a 3 in there. So we can simplify that by using the distributive property to multiply 3 by n minus 1. So we get, I'm going to recopy this, and we'll get and multiply 3 by the n, so that will give us 3, and 1 times 3 will give us 3. So we end up with this, which simplifies to 23, because we take the 26, subtract the 3, so it would be 23 plus 3n. And you may have noticed it does indeed look like a linear equation. where t to the power of n is y and n is x. So it does look like that, and you would be right in saying that it is correct. It is equivalent to y equals mx plus b, where your common difference is your slope. 23 in this case would be your y-intercept. N is obviously replaces x, it's equivalent to x, and t to the n would be y, if you're comparing it to y equals mx plus b. So this is where it's beneficial, because I know some of you are saying, why are we doing this? I could just continue the pattern. If we're looking for the 50th term, we don't want to add 3 every single time. So what we can do is we can simply use our formula to obtain that answer. So I'll use you can use a simplified version for the general term, either one, it doesn't really matter. I'll show you that both work. I'll just plug them both in. So if I'm looking for the 50th term, so I put in t to the 50 is equal to 26. I replace n with 50 minus 1, which would equal 26 plus 47. 47 times 3, which would equal 26. Plus, again, you don't need to do every little step that I'm doing. Oh, sorry, that's 49. Let me fix that. Thank you. 147. I'm a step ahead of myself there, which would equal 173. So the 50th, what this means is the 50th term in the sequence is 173. A lot easier than writing out 47 more numbers in order to get that, right? Or we can use the simplified formula for the general term, which is t to the n is 23 plus 3n, or you could rearrange that as 3n plus 23. It does not make any difference. Let me say that equals 23 plus 3 multiplied by 50, which would equal 23 plus 150, which is equal to 173. So either one, using the given formula that we will get this formula right here, and then you'll have to fill in what we have, and either one, the simplified version, you get the same answer, of course. The next one we're going to look at is the D, example D, 4D, and it says which term has a value of 503. So this is where you're at. This is the general term. So the general term is 503. You're given what the term is, or what the value of the term is. Now you have to find the term. So again, we're going to use the same formula up at the top. Again, you can use either one. It'll work. So you're going to copy this, and we're going to paste it. This time we are looking for n. So we're trying to figure out what term it is. So we have the 503 goes in for the nth term, because that's what they're asking for, is the value. And then we solve. So the first thing we're going to do is we're going to subtract 26 from both sides. So subtracting 26 from both sides, we get 477 equals n minus 1 times 3. We'll divide both sides by 3. And when we divide both sides by 3, we get 159 is equal to n minus 1. And then we add 1 to both sides. And we get 160 is equal to n. So that means that the 160th term in this arithmetic sequence is 503. Okay? So that means that the term 160 is equal to 503. That's it for examples 3 and 4. In the next video, we will do example 5, and then we will look at some application questions for this section. Thank you for watching, and we'll see you again. We'll hear from you again soon.